Myself, I'm Karthikeyan. I'm a Microsoft MVP. I have like 15 years of experience. And then I'm going to talk about deep learning 101. And this is most probably the one which I was started reading, and I thought I'll share this knowledge with you because I'm not an expert in this, no way an expert, but I learned something. So I thought I'll share it with you guys. And it's pretty much a complicated topic, but once you understand, it's basically some new things you need to know, and which is going to help us a lot. Maybe not now, or maybe a year later, or something like that. But still a good topic to know. And then we'll also talk about why you need to know as a developer. So that's a whole point, right? Okay, it's fine. So let's start. So why deep learning? Okay, deep learning is basically a technology behind driverless cars, behind Siri, Cortana, Google searches, image processing, automatic hearing, speech translation. It's everywhere. Okay, so deep learning is everywhere. Wherever you are feeling that you have a help to do, you need a software which does some kind of a wonders, then that might be a deep learning. Okay, so knowing that is far better. Okay, so why should I care as a developer? That's the whole point, right? So yeah, there are certain things that is happening, lots of things happening in the world. As a developer, why should I care? Okay, that's the thing you need to know. So why should you care is, you should care because deep, even though say, let's say a deep learning model has been created by your data scientist team in your, say, data scientist in your team, or the one which is on the other project. What it needs to do is it has to retrain every time. Okay, so in data has to be inputted, there might be some changes in parameters, there might be under different algorithms or anything else. Okay, so basically it needs to be retrained, not even the algorithm. So you, first thing is, you'll be using those deep training models to consume it. So to rather than consuming it as a black box, it's better to consume it as a normal usable interface. Okay, so that's the whole point, right? You have to make sure that it's consumable. That is also a pretty much important one. Okay, let me what I'll do is I'll put this 1 second. Let me check this guy. All right, okay, perfect. Okay, so that's the whole point. So so I've given an API from a deep learning model, so they should be able to what, they should be able to use it, right? So you, rather than knowing it and using it as a what is that, black box, it's better to know what is underlying the black box. And also, if opportunity arises, you might slowly get into the team and then start learning deep learning models, and your career gets better because it adds one more things to your resume. The whole point is, see, the data is growing. Okay, it's like zettabytes of data are available in our computers. Okay, so because of the social media, how the people can relate it to each other with the social media, they can take your phone number and then relate to your Facebook, they relate to your SSN, they relate to your Aadhaar card, then come back to your bank account. It related to something you liked in say some meme sites, something you liked in somewhere, something you bought somewhere. So people can track you like crazy, and those data are all available in open. Some are anonymous, some are not anonymous. That's a topic let's not go there. Okay, so this is a topic where you're gonna, the deep learning is needed by you. Okay, so even though you are not a deep learning scientist, you should know it because it's under the box. It's a black box. If you know it, you'll deal with it better, and you never know when you will be able to write your own deep learning models, build deep learning models, because things, each and every day, things are getting easier and easier. And most of the time, I don't want you to be left out, and even that's why I started learning this, because I don't want left out when things gets better. And then I'll be like, I don't know anything about deep learning. Okay, so when I know certain algorithms, or sorry, certain vocabularies, what I will do is I can give some inputs in the conversation that might help my career also. Okay, so that's the whole point. Okay, so let's talk about, I mean, we have been talking about machine learning from the start. Okay, so we've been talking about it a lot. Okay, but what we'll do is we'll make sure that we'll understand it in a better way, because it's nothing wrong to know certain things again and again, so it becomes your second nature. You don't have even have to think about it. That's how we read tables and all, right? 1 2s are 2 2 2s are 4. So that's how we read it. It makes sure that becomes a second nature. We don't even have to think what is 10 into 10 times 1 16. So it's like just comes it. So that is the whole point of this event also. Okay. So the first thing is the traditional programming. You put in some rules, you put in some data. So what we do is, okay, there is a requirement that comes in. What business analyst does, he comes and sits, okay, you know what, this the business has to go this way. So what we'll do is these are the rules you should follow, and then add the customer as a data, and then you write some code and you get an answers. Okay, that is how the initial um, traditional learning goes on, right? Traditional programming goes on. Okay, but in case of machine learning, it's not like that. You know what? They collect a lot of data. Say let's take some weather data. Okay, in the weather data, so past 15 years, on January, the weather on say January 21st was like this, January 22nd was like this. So when you do all that stuff, so you have an answer, right? The data is there, which is the past data. You have answer. January 21st data was say 22 degree 22 20 or 30 degrees centigrade. So you have the answers. What you do is you push that into a machine learning and gives you rules. Okay, it can be any rules. Okay, so it gives you some kind of a formula which can calculate the rules. Okay, we'll figure out in the next slide, going forward slide, we'll understand uh, what are the rules it's there. Okay, so that is the whole point. So it's a difference between traditional programming and machine programming. Okay. Okay, somebody said it's not showing full PPT. uh, is it not visible still? I think in YouTube I can see the full PPT. I think I can see the full PPT. Is there any problem with the PPT? Uh-oh. But I can see the PPT in my YouTube video. If possible, reduce. Oh, okay, okay. Reduce size. Understood. Got it. Okay. Okay, now I think you can see my video. Thanks for the feedback. Okay. So fine. So this is the case. What I will do is, so this is the traditional programming with machine learning programming. So where I told you, right, initially the business analyst and us sit together, take the data, developers start writing the code, and then we'll write it as a and it gives you answers. Right now, what we do is we already have a data, take weather forecast. We take the past 20-year data. We know exactly what will be the weather in January, and we can even drill down to January 21st. Okay, and then we'll doing it in a different way. So data, answers, and then pushing it, and then we figure out the rules, and then take the rules, and then again get the answer. Okay, it can be any formulas. Okay, so some formula it will give you some f of x. Okay, nothing else. Okay. Okay. So what's the difference between machine learning and I mean the slide is wrong, so it should be deep learning. Okay. So what's the difference between machine learning and deep learning? Okay. So machine learning and deep learning is I think I put everywhere as traditional learning. It should be deep learning. Okay. What I'll do is I'll go ahead and change it. Okay, so difference between the machine learning and deep learning is what? Machine learning is something we actually think about it. Meaning, so it's a. Hold on a second. Let me get all my slides. So can you see that? So can you read those slides? Meaning the difference between the machine learning and deep learning, and just let me know if it makes sense to you. Okay, so as you see the normal, as you can see the normal slides. Okay, So I'm gonna. So I just found the mistake now. I have corrected it right now. Okay. So when you see the slides, what happens is it is basically what it's a. It says one says you can make intelligent decisions, and the other also says the same, but it says it can add more representation computed in terms of less abstract ones. Okay. So okay, so that's kind of complicated, right? Like you don't understand. So it's too complicated, correct? Okay. So it's pretty complicated. And so let's break it down so that we understand what it is. That's the whole point of this meeting. So we'll understand deep learning very deep. Okay. So um, yeah. So let's break it down. So let's see step by step. The way I learned was like I started learning in a very steep manner, and then I started, okay, you know what, it's not working out. Let me go down, get understand the basics better, and then come back. Then it was easier for me to actually take it forward. Okay, fine. So okay, so can you guys find the pattern out of this? I think people, if you would have attended my event, you would have seen the pattern. Okay. So find the pattern. So how do you think out of this data I can see whether it's fraudulent or not? Can you guys answer that question in the window, chat window? So go ahead and answer this pattern. Find the pattern and then answer it. So how do you think out of this data, sometimes it says fraudulent and sometimes it's not fraudulent, right? What's the data that says it's a fraudulent? Can you just do a kind of analysis out of the data and tell us, okay, you know what, if I give you a new data, how can I manipulate it? Meaning whether you can say it's fraudulent or not. So how do you say it's fraudulent from the data? Tell me the pattern. Yeah, the first thing is used in Russia. What else can be? What else the document? What else the pattern can be? Used in Russia. That's a great point. What else can be the pattern? Okay, less age means likelihood of fraudulent. Yes, looks like that. Yes, good, good. What else can be there? Okay, correct. Issued in Russia, not in. Okay, there is no data with one which says issued in Russia. Okay, age below 40, good one. Anything else? Anything else with respect to the amount? Anything with respect to the amount? Okay. If you see there, if the amount is less than $1,000, even if it is issued from where issued, still there is no fraudulent, right? So basically, the higher amounts are being done fraudulent. Okay. So that's the point. Yeah. So you understood, right? That's a point. So that basically means that there are two things you need to know. The vocabulary you need to know. The vocabulary are features and labels. That is like very important. Okay. Whatever you drive out of this is you have to know what is a feature and what is a label. Because if you sit in a interview, sorry, if you sit in a meeting with all your data scientists or anybody who's working on AI, they're going to talk about features, parameters, stuff. I mean, all this stuff. So feature and label are the one they're going to talk a lot. So until you know what a feature is, you will not understand what they mean. Okay, so it's pretty much important you get your features and labels into your head. Okay, so feature is something which is your the actual input. Okay, so name, amount, where issued, age of card holder, whatever it is. Okay, and the label is the output, whether it's a genuine or fraud transaction. So that is the input outputs, and you have to know these features and labels. So it's very much important. You actually make sure that you understand this features and labels. Okay, features is just an input, labels are the output, what we expect out of the data. So okay, features is the data we are going to manipulate, and label is the data we are going to get. Okay, right, fine. So remember that features and labels. Okay, next thing. So what's the difference between machine learning versus deep learning? Okay, now we are like getting there. Okay, so you understand. I give you a data, and then I am telling you what the answers are, what fraudulent or not. Data is like USA, Russia or USA. Answer is fraudulent or not. Next time I come up with some other input, what happens? You'll tell me whether that can be a fraudulent or not, right? The fraudulent can be if it has originated from Russia and the age group is less than 27 and the amount is more than $2,500, what it might be fraudulent, correct? So that is what machine learning tells you. But in case of machine learning, what we need to do, we need to take the feature extraction, meaning I have to tell what is a feature, meaning take care of all these parameters, correct? One, you have to take care of these columns and then make sure you get me output. But in case of deep learning, that's not the case. Okay, if the deep learning will take care of what are the features it has to take. Okay, you just feed in the data. You don't have to tell, you know what, ignore this data, not ignore this data, ignore this parameter. You don't have to do anything. Okay, it identifies a feature by itself from the data, every data, and then it applies the algorithms and then gives you output. Okay, that's the difference between the deep learning and machine learning. You get it? So that is very important here. There is no manual process in feature extraction is the key difference between machine learning and deep learning. Okay, that's a difference in case of our work. Okay, so most probably we like deep learning because the manual extraction is pretty much less, and if you figure out a normal algorithm and better algorithm, you don't need a proper data scientist to do a feature extraction. But yeah, you still need a data scientist, but not that much in case of deep learning. Okay, right. So what are the problems that deep learning and machine learning solves? Okay, deep learning solves the problem from end to end. Okay, but in case of machine learning, you have to break down the parts first and then bring the data and then go one by one, and then only you get the final result. So there you might be using say 4 different algorithms to get a one single output. Okay, that is machine learning, and machine learning takes lots of time to um, run initial model building. Okay, so that is like huge time. It makes might some might take lots of days also. Machine learning most probably will take few hours or minutes to complete and then it work. But in case of uh, after the model is created, if you want to test it, deep learning is faster than machine learning. Okay, because the model is being very much synchronized and I mean it's very much optimized. So after the model creation phase, testing phase, deep learning is faster. Okay, let's dive deep down into basics. Before that, let me check any comments are there. If you have any question, let me know. If I'm going any faster, let me know. I'll just come back. Okay, so we still have some time, like 15 minutes, so you should be able to see things. Okay, so let's. I don't think there are any questions. I'll just move forward. Okay, so we have to know these things in case of deep learning. Okay, one is neurons and one is neural layer, one is network of neurons, activation function and weights. Okay, these are all sounds very much sleazy or very complicated, but it's not complicated at all. Okay, it's actually we already know it. That is how it works. So it's pretty much interesting one. I like it a lot. Okay, somebody has asked me how to extract feature manually. See, feature is nothing but a column, right? The columns, whether I need this column or not. Okay, sometimes you do, if you take a normal the pattern recognition, you might not need the name of the customer. Okay, but so you have to remove it so that the formula does not get affected. Say if there are customers whose account is name is got starts with J, and then what will happen is next time customer comes with the J, what will happen is machine learning might tend to give you a wrong answer. So what data scientists will do is they will remove the feature that is irrelevant. Okay, and then they'll give you only the features that might be useful. Okay, so they do a normal analysis and bring a rules out of it. Okay, that is what called feature extraction. Feature extraction is figuring out what are the columns that are needed. Okay, but in case of deep learning, you just push all the data, whatever you have, it figures out by filtering it, because the data goes back and forth, back and forth, back and forth, and you get the output. Okay, so we'll see to that. That's a good question. Thank you, Jay Sharma. Okay, so we need to know neurons, neural layers, network of neurons, activation function, and weights. Okay, so you saw neurons, right? Neurons is what? This is some. If you look into your 7th standard or 5th standard, 6th standard books, you will see some neuron, dendrites, axon, and all, right? It's actually because the concept came to the deep learning from this biology book. What it means is the multiple input is given, okay, and you get a single output. Okay, that's the whole point, nothing else. So you get lots of electrical impulses to the nucleus, and the nucleus takes care of sending that same impulses through the axon to other nucleus, other neurons. Okay, so that is the whole point. So neuron is nothing. You already knew what is neuron, right? In deep learning, you call it as perceptron also. So that is what neurons are. Okay, it's just a one single entity which can take input, give an output based on some function. Okay, just keep now right now keep it as a function. We'll see an example later, so we'll understand better. So neural layers are multiple neurons stacked or connected to each other. Okay, that is nothing. That is a neural layers. Okay, so what a neural layer is? Multiple neurons connected to each other. Okay, and then neural networks are the one which you normally hear are the neural networks that are connected in horizontally. Sorry, yeah, horizontally. Okay, so that is what multiple they call as hidden layers. Okay, let's not get in there. We'll come back to that. So this is what neural network is. So neurons are normal neurons which takes an input and multiple inputs give you an output. Neural layers are connected neurons. Neural networks are connected. Okay, and then yeah, this one is activation function. What activation function does is this is nothing but your normal neuron. We compare it with the deep learning. Okay, how do we compare it? Is we compare it in a different way. Okay, so we saw here there are dendrites, and then there are input that comes in, and then there is a cell body. Okay, the cell body is the artificial neuron. So basically that's the neuron, and there are multiple inputs, and then there is an activation function which gives you an output. Okay, so we'll come back to this again. Activation function is nothing but takes multiple inputs and gives you a single output. That's it. You just need to remember that. So activation function is some f of x. Okay, I'm not boggling your mind with some normal. That's an f of x, right? Right? You would have heard it like multiple times. We don't know why we heard it or why we started. F of x is equal to x squared plus x plus 1. And then if x has a value between 1 to 1, what will be the value? 1 squared plus 1 squared plus 1, which will be 3, right? So that is what we normally do. So that is f of x we are talking about. That's some activation function. Some input comes in, then you get an output. That's all. That's just an f of x with a given input. Now let's see what is weights. Okay, weights are nothing but proper 1, 2, 3. Okay, so let's take an input. I have multiple inputs and weights are say 5, 6, 7. I apply to a function. Okay, the function can be any function where you add and multiply and add. Okay, the whole deep learning methodology works on this way: multiply and add, multiply and add, multiply inputs and weights and add. Okay, so what they do is they do it in a multiple different ways. Okay, it can be 1 into 7 plus 2 into 5 plus 3 into 1, or the other way around also. So it will come up with so many different permutation combinations and give you a certain output. Okay, when the output is not right, it goes back to that. So why deep. So the point is it not? This is how the actual car is even driven? Okay, figuring out what weight will give you a proper output is the important thing. Okay, the weights can be 5, 6, 7, 9, 8, 10, 11, 12, 13, 14, 15, 16, can be anything. Okay, the decision is making on F38. Okay, let's take a driving the car example. Okay, so the input is basically what the car is going straight. Okay, and then the things that changes are the weights. Okay, so there might be a bump in the road, or there might be a bump in the uh, driveway, or somebody comes in there, it has to break, right? So these are the inputs, the weight gets calculated and it gives you output. Okay, whether that output is correct or not, it's being learned on the next layer. Okay, so we'll see what the next layer is. So first understand the f of x. It's like the weights can change and it keeps on changing and figure out an output. So f of x is the pretty much important. Okay, so you have a multiple. Now if you can compare this whenever you see a deep learning model, that is what it means. So it's a neural networks. Okay, multiple networks. Think about activation function also. So it's basically what you take a neuron. The neuron has multiple inputs that comes in. Okay, and then what it does, it actually processes with an activation function and then passes the same output. It gives you only one output to some other neurons. Okay, so it's basically that. So the same example, if you see there, there is a neuron, there is a cell body, an activation function, and an output. So when you compare the same, it is the same thing that happens. Okay, so just think about it. Compare these two, this one and this one. So it's all the same. The neuron, the activation function, multiple inputs, one output. Neurons, activation function, multiple inputs, and one output. So that is the whole point of deep learning. Okay. All right. Next, go to the next slide. Okay. So if you see this, so this is basically a neural network where there is one neurons. Okay, and then it passes from one layer to another layer to another layer to another layer, another layer. The layer, actually the size of the neural networks changes smaller and smaller and smaller and smaller, and then it becomes a output is cat. So we saw neural networks, right? So neural layer is here. So the neural layer is the first layer, the bigger one, and neural network is the multiple. So it's your layers become smaller and smaller at the end, and it gives you output. Okay. So the point is, it goes backward and forward when there is an input problem. That propagation is like out of the scope. Within the 25 minutes, it's not possible to explain, but we can do it maybe later. Okay. So this is the whole way the deep learning works. So you understand the four things, right? The neurons, neural networks, and the input and output goes in. The output is always one. It can be multiple inputs from one layer to another, and it gives you a cat. Okay, so there are lots of packages that use Kera and all those things. But if you want to learn any ML things, what you need to know is actually you need to learn Python or Scala. Python is pretty much easy. It will take not more than an hour for you to actually start using it. Okay, start learning it. If you are like a very good programmer, you will not even take an hour. Actually, you'll just need to understand the logic between you just need to understand the logic between the uh, sorry, the structure between the if and for loop and how tab works. That's all, nothing else. It's all the same. They have got like very great packages for each and everything. You need to know just the packages and call it. You will get an output. So should be okay. Syntax will be a little bit problem. Otherwise, but Visual Studio corrects it for us. So Visual Studio with Python is deadly. So start learning Python. I would highly recommend that. Do not hesitate. Please learn Python. Okay, fine. So let's go to demo. Let's see whether people can see my screen. Okay. I'll wait for you guys to tell me whether that my demo works. Okay. So Sivapan was asked what is weight. Okay, weight is nothing but the uh, multiple permutation combination we need to try so that the output is got. So if you see f of x, there will be 5, 6, 7, right? It can be 10, 11, 12. Okay. So say if I drive a car, do I need to turn right or left? Okay. So how it will do? So there will be multiple inputs that will be coming. Okay. So that way I'll be able to see. Okay. I think the demo also works fine. Okay. Good. So what I will do is I'll go ahead and open the notebooks. Okay, so this is a simple demo with using Kera, and the what you're trying to do is you're trying to run the so this notepad that people have used like in notepad, notebook. They've used in multiple sessions. See, the whole point of event is to bring you into a place where you feel more comfortable with these environment. Now you are very much pretty much understand what machine learning is. You pretty much understand the language Python, meaning you have to learn it, and then the notebook environment. Okay, so what I'm gonna do is I'm gonna start it. Okay, so yeah. So the point is, so this is the environment which normally we use. Okay, so let this start. Okay, so what this is a notebook you just should try your hands on, because Databricks is some trial period is there. You can start using it. Okay, so Python works perfectly fine. So what you do is, this is the code which what it's doing is it's actually reading the blob storage from the zip file, and then from the zip file, and then extracting it to a multiple files into the blob folder with naming it. So if you can see that this is the one which is already run. So it says os, dog, and all. Okay, so with the file names. Okay, so category list it has categorized, and then based on the images they already got. Okay, so this is already done. So I have run this before. So do you see the output? Can you see the output here? Okay, okay. So I think the next one might take a little bit more time to run. Let's see whether my cluster is started. Okay, I want to explain it to you rather than running it, because it'll take on lots of time. As I told you, it will take lots of time to actually run. Sometimes it throws error, but it worked, completely worked. Okay, I tested it. Okay, so let's not get into that. So these are things you need to know. One is the Keras, which is used for the library used for deep learning. Probably all the types which is with respect to the uh, image processing, and the NumPy for the numerical works. Okay, and then this one actually extracts your all images and gets your mounts into the clusters folder. Okay, so it can be used later. Okay, and then we'll be initializing all the parameters, how much batch to run. The CFAR10 dataset is nothing but the all the image set. Okay, and then this will tell you all the float types we need to know. Basically, this is nothing but adding the key properties for the Kera software to start using it. Okay, so this is like the written one, and you can figure out what are the optimizers that we can use. There are multiple optimizers in the Kera software which you need to select, and so this is like once this has been done, the model is being created. Now we are trying to evaluate the model, and this will evaluate the model as I told you, and it will also give you a graph. Let's see whether I can run it. The cluster is taking lots of time to run. Hold on, I don't know why. Okay, so that's the whole point. So you need, it's the same thing, right? We saw on this scenario where so basically what we have to create get the input, and then feature extraction and classification is done by the deep learning methods using Kera, and then the output is the model, and we are testing the model. Okay, most probably it will take some time to run. So what I'll do is I'll let it run and then wait for questions for you guys. So is there any questions? When you want me to repeat anything, I can repeat it to you because it will take some time to run. I showed you the output already, which was run. So again, I'll reiterate. Okay, the point is you need to know what is a neuron is. Neural networks are an activation function, weights, and how data moves from one point to another. So that's the thing you need to learn, and it will take some time for you to get hold of it, but it's a good start because it will take at least for you to be around here just for 2-3 months, watch some 2-3 videos to actually understand how things goes. If you don't understand now also it's okay, but you would have got the gist of it. I'm damn sure about it because I made it dumbed down and then put you like certain things on top of it. You can actually now compare and learn. That's the whole point. Okay, so you can actually compare this neurons which we learned before, and then see neurons, and then this activation function, the sandwich. So the weights is the one which might change, and it will give you a different output, and then everything fits together, and then if it doesn't fit, the layer propagates back. Okay, just remember this. It's basically some f of x where the weight changes, and it can take any different random numbers, and then figuring out what can be the weight, meaning what can be the action I should take, or what are the images I should do, or what are the, if in case of cat and cat images, it can be, the weights can be multiple. Say if you say that cat, let's see whether I can do something. What I will do is okay. So okay, I think good to go. All right. So is there any questions you have? Okay. So let's see when not to use deep learning. Okay. Yeah. So okay. So when not to use deep learning is when the data size is too large. What we'll do is I think the demo is taking much time. Let's not waste time here. Okay. So um, when the data size is too large, what we'll do is we'll not be using the machine learning. Okay, we'll be using deep learning. Okay, and then deep learning needs a very high-end infrastructure. Okay, and then if there is a lack of domain understanding for feature introspection, should meaning when the deep learnings are used in places where if you have a lots of the domain, not you don't have a domain knowledge. Okay, so that if you have a domain knowledge, you use deep learning. If you don't have a domain knowledge, sorry, if you don't have a domain, use deep learning. Otherwise, you can use machine learning, and also come back and forth. Okay, and deep learning really shines in complex problems, not in simple problems. So don't use for simple problems. Do not use deep learning. Use it only in places such as image classification, natural language (NLPs), which Rajesh spoke about, in speech recognition. So those are the, yeah. So somebody asked me the question about what are the Azure tools for. Okay, the tools are use the Scala, sorry, use the Azure notebooks, use the Databricks to ingest data. So those are the tools that is available for deep learning, and then normal Python libraries are superly available. You can just watch the notebooks which Vijay Perumal spoke, understood what Azure Databricks, what Niveda spoke. Also, you saw Aris and uh, Satish's machine learning. And then when you come back to this, you will